Hi, my name is Jessie Keaveney, and in this video I'm going to be going over the time value of money practice problems with the solutions in Excel. These problems were created by Dr. Panta for Brenau University, and I am going to show you how to do them in Excel. So the first problem is, if you wish to accumulate $140,000 in 13 years, how much must you deposit today in an account that pays an annual interest rate of 14%? So the first thing that you need to know is what you're trying to find in the problem. So you are trying to find, it looks like the present value because it says how much must you deposit today in an account. So what I'm going to do is I really like to use problems in Excel and copying and pasting the formulas over to a problem and changing the input so that it will calculate. So if we're looking for the present value, we're going to take this formula. So you're going to highlight it. You can see in here in orange it's looking for the present value. Right click and copy. You can also do this through like up here on the screen, or you can do like a Control V. I just like to right click and copy, and then you're going to go back to where you want to click on the cell and then right click and click paste right here. And then we're going to change the inputs, and so in blue is your inputs and in black is usually a formula. So in this case it's asking for in 13 years, so you're going to key in 13 here, annual interest rate of 14%. The future value is $140,000, so that's what you're going to accumulate, and your payment is 0 because in the problem it didn't mention a payment. And so in this case it calculates in Excel to be $25,489.71. Okay, number 2, it says what will $247,000 grow to in 9 years if it is invested today and in an account with an annual interest rate of 11%. So you're looking for the future value because it says what will it grow to in 9 years. So if we go back to a problem that has a future value, and so when you're doing your problems or like your exam, what I typically like to do is have formulas ready to go. So I'll have like future value, present value, interest, in payment, things like that already open in a separate screen so that I can easily copy and paste them into whatever I'm doing on the final exam. So it's just a matter of copying and pasting. So I'll go here, we're looking for future value, so I'm going to right click and copy. Go back to where we're doing our problems, right click and paste. So what will $247,000 grow to? So the present value is $247,000. 9 years is in an account with an annual interest rate of 11%. So that gives us a future value of $631,835.12. All right, number 3. The problem says how many years will it take for $136,000 to grow to $468,000 if it is invested in an account with an annual interest rate of 8%. So we're looking for we're looking for the number of years. So I'm going to go back here, find a problem with in, right click copy, go back over here, right click and paste. How many years will it take for $136,000, so that's your present value, grow to $468,000 if it is invested in an account with an annual interest rate of 8%. So that gives us 16.06 years. Okay, number 4. At what annual interest rate must $137,000 be invested so that it will grow to $475,000 in 14 years? So we're looking for I. So if we go back over here, here's one with I, so copy. Go here, right click and paste. At what annual interest rate must $137,000, that's your present value, be invested so that it'll grow to $475,000 in 14 years? And that gives us 9.29%. Okay. Number 5. If you wish to accumulate $197,000 in 5 years, how much must you deposit today in an account that pays a quoted annual interest rate of 13% with the semi-annual compounding of interest? Okay, so it's looking for the present value because it says how much must you deposit today. So if we go actually up here to present value, right click, paste here. So you want to accumulate. The future value is $197,000. Okay, it's saying in 5 years, but you have semi-annual compounding of interest. So that means every 6 months you're going to be compounding interest. So the N is actually 5 years times 2 because you earn interest twice a year. Okay, and then I is you're going to take whereas in N you multiply by 2, in I you're going to divide by 2. So you're going to say equal 0.13 divided by 2. Okay, so that gives you a present value of $104,947.03. So remember, when you're doing when it says semi-annual, you've got to fix the N and you've got to fix the I. But the N, in most cases, you're going to multiply, and I, you're going to divide. Okay? In number 6, it says, how much money would you have in 13 years if you deposit $153,000 today in an account that pays an interest rate of 10% compounding monthly? So how much money would you have in 13 years? So you're looking for future values. So we're going to go up here, right click, copy, go down here and paste. All right, so it's looking at 13 years, but it's compounding monthly. So you're going to multiply by 12 because there's 12 months in a year. And it's an interest rate of 10%, so equal 0.10 divided by 12 because there's 12 months in a year. And then the present value is $153,000. Okay? So that gives us a future value of $558,386.38. Okay, next problem. How many years will it take for $197,000 to grow to $554,000 if it is deposited or invested in an account that pays an interest rate of 8% compounding monthly? So we're looking for N. So we're going to go up here, copy one that's looking for N, go down here, right click and paste. So your present value is $197,000. Your future value is $554,000. And it's 8%, but it's compounded monthly. So you're going to divide by 12. So the N it's going to give you is the number of months because it's saying that it's compounding monthly. Well, to get the number of years, you have to take that divided by 12 to get the number of years. Okay, so the next problem, it asks, at what quoted annual interest rate must $134,000 be invested so that it will grow to $459,000 in 15 years if interest rate is compounded weekly? So we're looking for I, because it's asking for the interest rate. So we're going to go up here, copy, and right click and paste. So $134,000 is the present value, and it's going to grow to $459,000, so that's the future value. in 15 years. So it's 15 years times, and it's compounded weekly, so there's 52 weeks in a year, so you're going to multiply by 52, okay? So this interest rate is based on a weekly basis. So to get it on an annual rate, you're going to take the weekly interest rate times 52, and this would equal the annual interest rate. Okay, number 9. You are offered an investment with an annual interest rate of 13% compounding quarterly. What will be the effective annual interest rate on this investment? So, if we go back to a problem down here, this is one on your textbook problems. This is an Excel template for the effective rate. So if you go find it, right click and paste, saying 13% compounding quarterly, and there's 4 quarters in a year, so that's 4. So the effective annual interest rate is 13.65%. Okay, the last problem that I'm going to do in this video for part 1 is you are offered an annuity that will pay $24,000 per annum, or in other words, per year, for 11 years. The first payment will occur 1 year from today. So that's an ordinary annuity because the payments occur at the end of the period. If you feel that the appropriate discount rate is 13%, what is the annuity worth to you today? So, you are looking for the present value. So we're going to copy that, go down here and right click and paste. It's going to pay, so under payment you're going to put $24,000. It's got 11 years, 13%, put 0 for the future value, and it gives you, it's giving you a negative present value of $136,486.59. All right, that's it for part 1, and I will come back and I will do a second video for part 2. Thank you very much.